Hello, I am Dr. Rajesh, working as assistant professor in GMN College, Ambala, Kent. Now today I will be discussing with you the concept of central orbit, and in the very same lecture we will try to establish that the central orbit curves are planar curves. So firstly we will see what is central orbit. Let us consider any point P and OB a fixed point, and OP is the position vector, R is the position vector of P with respect to O. Then the motion that this particle at point P describe such that it is always, its force of attraction is always directed towards the center, then that kind of motion is called central orbit, where particle P is describing motion such that its force of attraction is directed towards the fixed point O. So that kind of motion is called central orbit. The force of attraction is always directed towards the fixed point. So we can also understand its definition from its name. Central means having motion about the center. Orbit means motion. Orbit means path. Orbit means motion. Central means about center. So motion about center is, that means the force of attraction is always towards the center. So this definition is very much easier. So you have to write something like that. The central orbit are those orbits in which the force of attraction is always towards the center. For an example, we can give these planets are revolving around the sun. This sun is the center and these are revolving around it, so they are describing the central orbit. Force of attraction is always towards the sun, so we can say that each of these curves are central orbit because the force of attraction is always towards the sun. Sun is attracting the planet, so that is an example of a central orbit. Force of attraction is always towards the center, so this is how you do it. This is always towards the center. Next we shall prove that this is an important question. Prove that central orbit is a planar curve. Now we write the general thing that this is O is a fixed point and P is any point on the curve. This is the curve and P is any point. Join this thing. This R is the position vector. You can write this is a fixed point, and I am going to write the meaning of R. R is equal to position vector of P with respect to O, and this dr by dt is the tangent vector at point P, giving the direction of the motion. Now this point P has the two kinds of acceleration. One is the transverse acceleration, another is the radial acceleration. Radial acceleration is always directed along the radius, and it is written as d square r by dt square. So I am going to mention it here that d square r by dt square is equal to radial acceleration and is away from point O, that is towards P. Therefore, this is the direction of the radial acceleration, and this is the position vector having this direction, and acceleration is also having this direction. Therefore, we can say that both the radius vector and the acceleration are in same direction. So we can easily write r vector is parallel to the acceleration vector, and we know that if vectors are parallel, this implies that their cross product is always 0, because we know that two parallel vectors have their cross product 0. Now this can be further written as r cross d square r by dt square plus dr by dt cross dr by dt equal to 0. So this will not make any difference, because we know that the cross product of two same vector is always 0. So this will be the same equation, and we have added this, so this is 0. So this addition of this is not making any difference, because a cross a is always 0. This can be further written as d by dt of r cross dr by dt equal to 0, because when we will apply the cross product differentiation of cross product rule, where we will keep this vector as such and will differentiate this, will get down, because we have applied the differentiation of cross product. This implies that this f is kept as such, this is this thing, and now differentiation of first and is kept as such. Now integrating both sides, we get r cross dr by dt is equal to some constant vector, say h, because cross product of two vector is again a vector, say is a constant vector. Okay, and this is a vector quantity because this thing is vector, and differentiation vector is also vector, and cross product of two vector is a vector quantity, and this will be a constant, so h is a constant vector. This is not only constant thing, it is a constant vector. Okay, fine. Also we know that r dr dt equal to 0, and name this equation as equation number 1. This thing is 0 because we know that scalar triple product is always 0 if any of its two vectors are equal. These two vectors are equal, therefore this scalar triple product is 0. So this can be written further as r dot r dr dt equal to 0. This implies that r dot h is equal to 0 by 1 implies r is perpendicular to this thing, implies position vector r is always perpendicular to constant vector. This implies that central orbit curve is planar. So how could we refer that? From this thing we were easily able to refer that this motion is a planar motion. So we will be discussing this in the short time, and that concept we will discuss that if r dot h is equal to 0, where h is a constant vector h is a constant vector and r is a position vector. So we have to establish the result like we take in 3D. This is x-axis, this is y-axis, this is z-axis. Now this is the motion, central orbit motion, and this is a point O, and this is the position vector P. This is the tangent vector dr by dt, and this is the radius vector. So we see that this is the radius vector. The constant vector, whether it is here, whether it is here, whether it is here, whether it is here, wherever it is, the constant vector is always perpendicular to this curve. So the only possibility for the constant vector to have a direction is along the z-axis. So I have to say that this is along z-axis. So if we see that z is along h is along z-axis, and this is in plane xy, so this is describing that the curve is planar curve, that particle p is following is a planar curve, that this particle following is a planar curve, and this is the direction which will always be perpendicular. If a particle is here, 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 and wherever it is, this is in along the z-axis, so it will always be perpendicular to xy plane. So this particle, this signifies, this guarantees us that this particle p is always in a plane, and whatever motion it is describing about point O is a planar motion, it is in xy plane. We can also illustrate it through the example, and I now these two examples, the curl right hand rule. In this case, this I is serving as h vector, and this curl is between r cross dr by dt. So when this is revolved, this gives out to be the perpendicular direction, that the cross between r and h. For an example, this is r, this is dr by dt, and this is in this direction and this is in this direction. Because velocity vector tangent is always perpendicular to the position vector, so this is this one, and their cross product is along the perpendicular, and this is h vector is equal to r cross dr by dt. Therefore this r and dr by dt are in a same plane. Hence we have shown that central orbit is a planar curve. So in this video we have discussed the definition of central orbit and also proved that central orbit are describing the planar curve. So in the next video we will derive the differential equation of central orbit in polar form, which is a very important question from the examination point of view, and I hardly believe that there is any time when that question does not appear into the examination. So we will, in the next lecture very soon, by tomorrow I will be uploading the lecture, and that is very important question, and please do stay tuned, and we will be discussing that in the next video. And if you have liked the video, so I would request you all students to share with your friends, those who are not able to attend the colleges and are from the different part of Haryana and are in your contact. Share this video, because I will be completing the whole of the central orbit through this video series within this month only. I will be covering one section completely. So if you want that your friends should be benefited and they could get out something out of it, please share. And so if you have liked the video, if you think that this is a useful video, please subscribe and share. Thank you for watching. This is Dr. Rajesh. Thanks.